Good afternoon. Today I will be discussing the pathway for sound transduction, or otherwise known as auditory transduction, or hearing sounds. Most of us are blessed with hearing and take advantage of the fact that hearing gives us a gateway to our surroundings and the world around us. Starting first with the three parts of the ear, the outer, middle, and inner section, we will look at how they play a role in our ability to hear. Then we'll look closely at the cochlea and lastly discuss specifically the process of transduction, which is converting sound or external stimuli into electrical impulses that our brain can process. This image shows the three sections or the parts of the ear. The outer ear is shown here, represented by orange. The middle ear is represented by the objects colored in pink all the way down. And then lastly, the inner ear, which is represented by this blue colored object. The external or visible portion of the outer ear is called the pinna. A lot of us would think of this as being the cartilage portion of our ear or part of our earlobe. It is the part that we can physically feel and touch. And then inside we have our ear canal. This is also known as the external auditory canal. Within the ear canal, sound is amplified. It is a funnel shape which tapers smaller the farther it goes in towards your head, away from the outer portion of your body. And at the end of the ear canal lies the tympanic membrane. This is an oval-shaped membrane commonly known as the eardrum. The stimulus or sound from the external environment travels through the pinna, down the ear canal, and then vibrates the eardrum, or the tympanic membrane. Here you can see a zoomed in portion of the middle ear. In the lower corner, we have more of the entire portion of the outer, middle, and inner ear, and then here we have our zoomed in portion of our middle ear. The beginning shows the tympanic membrane labeled as the eardrum here, and how it is connected to three small bones via ligaments. So here you can see the ligaments that are connecting that tympanic membrane to these three bones, which are known as the ossicles, or the small bones of the inner ear. These three bones are also the smallest bones located in the human body, and they are the malleus, incus, and stapes. These three bones or ossicles are responsible for further amplification of sound from the outer ear towards the inner ear. This amplification of sound is transmitted through the oval window of the middle ear to the cochlea of the inner ear. Here you can see the oval window behind the stapes, and then beneath it you have the round window. The round window vibrates in opposition to the oval window, assisting in the mechanical properties of the middle ear. On a side note, these bones are located in the tympanic membrane, which is this space here, and this connects to the eustachian tube that continues down farther. The eustachian tube is what aids in balance and equalizes or assists in equalizing air pressure within our ears. Back to our inner ear, the sound now traveled through the outer ear, through the canal, vibrated the tympanic membrane, and is further amplified by the ossicles transmitted through the oval window to the cochlea. This is the inner ear, and this is where sound waves will be converted from the mechanical waves into electrical impulses for the brain to receive and interpret. The cochlea is a well-known auditory organ known for its shape, which is that of a snail. So here you can see the ear canal the tympanic membrane or eardrum, the ligaments that then connect our 3 small bones or ossicles, our oval window, you can barely see the round window here, and then this would be our cochlea. And this here is the shape of the snail that is specific to our cochlea. When the sound waves travel through the cochlea from the outer window, there are tiny hairs that are found inside of the fluid-filled portion of the cochlea, and they vibrate, resulting in an electron or an electrical impulse that is then sent to the brain. The cochlea is divided into 2 sections, and these 2 sections or chambers are both fluid-filled and lined with these hair-like protrusions. Although the cochlea is divided into 2 internal chambers, the organ itself is physically divided into 3 sections. The 3 semicircular canals are atop the cochlea. They are represented by the circles. These are fluid-filled canals that respond to the body's movement and are responsible for allowing us to maintain what's called rotary motion. This is the ability to spin on an axis or spin like that of a fan and somewhat maintain our balance. The vestibular portion, which is noted here with a star, it's located right in this region. This is responsible for containing the utricle and the sacral, which allow for us to have our forward and backward motion and our up and down motion and maintaining balance. The cochlea again is that snail-shaped portion right here. And sitting, again, we had it divided into 2 internal chambers within that snail-shaped portion of it. And sitting on top of those 2 chambers is something called the organ of Corti. Here is where there are stereocilia or hair-like projections that are connected to nerves. These nerves are attached to the brain. This image does not show it, however, the nerves that are attached from the cochlea to the brain leave from this direction here and go outwards towards connecting to our brain. The movement of the fluid within the organ of Corti trigger the hair to respond, and that is what sends that electrical signal to the brain through that auditory nerve that I just mentioned. Auditory transduction is a simplistic term in saying that it is giving the sense of hearing and converting it into electrical signals or impulses. So here this picture represents auditory being hearing or sense of hearing. Transduction is essentially saying that it is converting it into an electric impulse that's then connecting to our brain to interpret as sound. And what is sound? Sound is created by vibrating objects, and it can travel through various mediums. Mediums can be things such as liquid, solid, or gases. An example of a liquid medium would be water, solid would be the floor, and gas would be something as simple as air. Lastly, as this image shows, all portions of the ear are necessary for or assist in ensuring proper function of mechanism of hearing, converting mechanical vibrations or waves from our external environment out here into our pinna through our ear canal, sends vibrations through the tympanic membrane into those bones, our ossicles, and then of our middle ear, and then converted from this portion all being mechanical or waves to then through the cochlea, which converts that mechanical portion into electrical impulses or stimuli. Converting that mechanical vibrations or waves from the external environment into electrical impulses is what allows our brain to take that information and give it to us in a way that we can understand, process, and interpret what it is that we are hearing. Here are my content references for the actual information that I was able to source and cite. And then here is a list of my image references for all of the different images that I used throughout my presentation. Thank you.